Good evening, Nano fam. Hey, Andefnal. Hey, Cruptor. Hey, LFLF. Hey, Jubu. Welcome back. Time to write some Rust code. 1401, you're here. Welcome. So let me add you all to the wheel. So, Jubu, you're added. 1401, you're added. Mark Sarno, hello, and Pies, welcome back. Alright, so you know the game. If you want to take part in the Nano giveaway, just post your Nano address in chat. Wenderson, Nano is the light, Nano ist das Licht. Wenderson, let me add you to the chat, to the wheel. Yeah, write your Nano address in chat if you want to take part in the Nano giveaway. And we give away 1 Nano every 10 minutes. So that's 1 Nano for roughly every Bitcoin block. So the timer is running. LFLF, cool shirt, good looking. Thanks, my girlfriend bought it. So let's switch to the spinner wheel. And so please check everyone that you're on there. I'm using the old spinner wheel, not because the new one is rigged, but because the new one doesn't load. It's the website I'm using, it's offline for whatever reason. So we are going to use this old spinner wheel. All right, so this week I got a lot of stuff done again. So we are really making progress here. But the old one is rigged, yeah. So unfortunately for everybody, this is the rigged wheel where only LFLF wins or Andefnal. Nanomark, by the way. Okay, yeah, so it was another very productive week because I finished the telemetry class that we worked on last stream. And then I spent the rest of the week porting all of the WebSocket code to Rust. When merge Andefnal asks, yeah, I had time for that. Cropter, do a spin test without giveaway to see if it is rigged. Oh, we don't have to test that. It is rigged. It is definitely rigged, guys. So all of the Nano will go to Andefnal and LFLF. Yeah, so I spent the whole week porting the WebSocket code, and I'm done. So now the whole WebSocket component is all Rust, and the old code worked with Boost and the Boost library, the part for working with WebSockets. I don't know the name, and I did a bit of research, and I saw that there's a really good Rust crate for working with WebSockets, and its name is Tungstenite. And then I switched the code to Tungstenite and Tokyo. Tungstenite plus Tokyo. So the WebSocket code is fully async, and yeah, it works with Tokyo. Not everyone is on the wheel, says Andefnal. Marco, I didn't get the name. Yeah, but I think I don't have Marco's. Hey, Mark Sarno. I think you mean Mark Sarno. I don't have your address. So if you want to take part in the spinner wheel, or just to make sure, let me check the address book, but I don't think I have you. Mark, no, you're not in the address book. So if you want to take part in this spinner wheel, yeah, just post your address. Reverse says, been a while since I worked with Rust. Yeah, so now you can refresh your Rust tonight. Andefnal says he did already post it on YouTube. Think address is on Twitch. Okay, let me just check. Oh, thanks, Andefnal. I missed that. It's up here. It's up here. It's up here. Here it is. Okay. So Mark. Yes. How was it written like that? And what's... let me just double check. Is that the name and the address? Oh, it's written with a K. And that's the address. All right. Okay, so I hope we have everyone on the wheel now. Reverse also. Reverse, and let me add you too. Reverse, and your address is this one. Okay. Okay. Renderson says, wow, great job. The node in Rust is almost there. Yeah, we are almost there. So let me switch to Vim, NeoVim, and let's have a look at node.hpp. The main class that encapsulates the whole running node except for RPC. And when we scroll down, the last bits are almost all ported. So as you can see, the only part missing now is the process live dispatcher. And that is a really small class that should not take long to port. What else is missing? Yeah, the bootstrap parts. So these two parts up here, they are partly ported. So I'm not sure how much work there's still left, but the bootstrap server and the bootstrap initiator, they still have to be ported, and then a small part of the network, and then we're done. Then we are done with the node. So I think it's just a matter of weeks. Oh, maybe I should not be so optimistic, because I have a horrible task in front of me, and the task is this. I am 100, oh, can you see it? Let's make it bigger. Oh. I am 126 commits behind now, behind upstream. So I have to merge that. 128 commits, and the team is still working on more commits. So I have no idea how much time that will take. So if there were no upstream commits, I think we would have the full Rust node in maybe 2 or 3 weeks. But with all of these upstream commits, I really can't tell how long the merge work will take. Yeah, but it's really looking good. Nastya NVR, hi. Nardo ETH is here. Hello all. Our Nardo ETH, you're also going to the wheel. Nardo ETH. Yeah, first giveaway in 2 minutes. Yeah, so that's the state. And then when we... let's have a look at the percentage, the ported percentage. (47.6). And that number is really low. That pessimistic. So we are actually a lot further than 47.6%. How much, I don't know. But I know it's, yeah, we are almost there with a full Rust node, except RPC and except CLI. But those parts are not important, really. Wenderson says, during the years, I have seen many others trying port the node to another language. You will be the first to achieve this hard objective. Yeah, I think so. And I'm really excited about that. And I think I'm also the only one who took the approach of incrementally porting it. The others, they wanted to rewrite everything. And that's just impossible from my perspective. Nastya NVR says, I'm learning SkillerDB right now. Never heard of that. It's pain. Okay. And 14.1 says, imagine doing a marathon and the finish line is mounted on a car driving away from you. Colin sitting at the wheel. Yeah, that's my feeling right now. That hits the nail. Yeah. Marcus says, non-tech guy here. What will happen if it is complete? I'm going to release an alpha version so that people can install it and play around with it and let me know if there are problems. And once we have it tested, I'm going to release a real release version, and then people can use the Rust node on their representatives. And yeah, that will be a major milestone. So, okay, so we are almost done here. The WebSocket code was actually, it is actually looking quite different now, because I had to port it or switch it from Boost to Tungstenite and Tokyo. And I thought, let's do the giveaway first. All right, everyone. The first nano of the evening goes to Raptor. Congratulations, Raptor. Congrats, Raptor. Oh, what's going on here? Preparing transaction. What's up with Nald? Is Nald having issues? Okay, now it works. That was a strange delay here. All right. Let's get back to the code. So for this stream today, I thought I would start with a bit of cleanup tasks. And I have no idea how this will, in which direction this will go. So the last stream was very fast-paced, so I expect this stream to be very slow. Maybe we will not write much code. Maybe I will end the stream early, who knows? I have no idea. Mark says, so it was not rigged after all. Hey. All right. Craptor says, thanks, I got it. Okay. Yeah, I have no idea. No idea how this stream will go. I thought I would clean up the WebSocket part, and maybe you guys can help me. Let's have a look at the code, and let's think about how we can make this cleaner together. Craptor says, I'm Gustav's alt account. Yeah. All of you are. Undefnal is me and LFLF is me. So I send all the nanos to myself. Yeah. So let's open up the WebSocket file. And that is in WebSocket. WebSocket. Yeah, so right now I have just two modules. 3 modules. The listener, the message, and the WebSocket server. And I think we should start by drawing some diagrams first, so that you all have a picture of what the WebSocket classes do. So let's start with the listener. The listener is... Oh, and I have to split this file up. There's way too much code in this file. Here, I like my files to be small. So here it is, WebSocket listener, and what it does is it listens for incoming connections, and then it spawns those sessions. So let's draw a diagram here. We have the WebSocket. We have the WebSocket listener, and we give it an endpoint, an IP address and a port, and it listens on that port for incoming connections. And yeah, let's just scroll down a bit. Where is the part where we start? Accept connection. Here. So this is the part where we start, and as you can see, we still have a mixture here of async code and non-async code. So the run is sync, and this then switches to the Tokyo runtime and calls the async run2, and run2 is a horrible name, so let's start by renaming that. So this is the same as the run, but it is async. So let's maybe rename the run to run sync. I'm not sure. I want to get rid of all of the synchronous code anyways. So let's give the worst name to this function. So I want to rename this to run sync so that we know this is a synchronous method, and that we can rename the run2 into run. So what does the run do? It binds to a TCP port, and then what does it do then? Yeah, so here, if you have never worked with Tokyo, so like me, this is like very interesting. With Tokyo Select, we give it 2 futures, and the one that completes first wins. So the stop is a one-shot channel where we can signal the server to stop. And so if we send the stop signal, this will complete because the stop message was sent. And this will then stop our WebSocket listener from running. And as long as we have not received the stop signal, this accept loop in the accept function just waits for incoming connections. And then it spawns for every new incoming connection. It spawns a new task, which handles the WebSocket messages. And so this is the accept connection. Yeah, so this launches a WebSocket session. So let's add that to our diagram. So we have a WebSocket session, and the listener creates those sessions. And here you see the same pattern. Again, we have a Tokyo Select. So we have a close channel where we can send the close message, or it goes into the run function of our session. And the run function does 2 things. It waits for incoming messages here and processes them, or it waits for messages from our nano node and sends them to the client. So we have these 2 functions. We have a bidirectional communication. We can send messages to our WebSocket from outside, and the node can respond. It can also send messages to the client. I hope this makes sense. And here you can see it uses tungstenite. This is the Tokyo tungstenite crate to send the message back. And also, I think the stream, as you can see here, the stream is a tungstenite WebSocket stream. So that library was really easy to work with, and it worked really well. So all the tests are passing. The tests are still in C++, so we have to bring them to Rust too. Maybe we will work on that today, I don't know. And I really don't know where we should start. So the WebSocket session has a run function, and yeah, so this is all. I wrote all of that code really quickly, so I think there's lots of potential for optimization here. So I had to split the web session, the web session into 2 parts, into 2 structs. And why, I don't remember, but we will find out soon again. So I split the WebSocket session into two parts with WebSocket session, and the other one was WebSocket session entry. And this is an arc, right? That was an arc. Yeah, this is an arc. And this WebSocket session entry I think this is kept in a hash map. No, in a vec. NanoFam, this stream will be really slow, and maybe we will not get anything done. I hope you are okay with this. Okay, here it is. So the WebSocket listener has a vec of weak pointers to WebSocket session entry. So let's maybe let's make this line dotted because it is a weak pointer. Dashed. And the reason for that is, so the listener has a list of sessions, and we use those sessions when we want to publish messages to all open sessions. And I did not use the same instance because that was caused a lot of ownership issues. And so I split this into these two parts. And the session entry struct contains subscriptions. Yeah, so subscriptions. So when you connect to the WebSocket, you have to subscribe to a topic. So there's an enum called topic. Topic. Oh. So you have to subscribe to a topic. And only then you will get messages, and only those messages for that topic. The second thing it has is the send queue. And we need, so this is a multi-producer, single consumer channel. So we need this. I didn't hear the giveaway music. You're right. Why? What's wrong with the giveaway music? Weird. Oh, a new Bitcoin block appeared. I didn't hear it either then. Let's do the giveaway. Any new nano addresses? No. Oh, Craptor says also giveaway time. Reverse says, what tool are you using for drawing the diagrams? It's an online tool and it's called xcalidraw. So just go to xcalidraw.com and they have a free version and a paid version. Oh, who won? Nardo ETH. Let's send 1 nano to Nardo ETH. Congratulations, Nardo ETH. So yeah, so we subscribe to a topic and only then we will get a message. Oh, and message is also missing. So we have a struct called message. And let's have a look at that message. So the message, a message always has a topic. And then it has just a JSON button. Oh, here, I think this is a good starting place. Yeah, so it has a contents. And that contents is right now it is 30 property tree. And this is historic. So the C++ code uses the boost property tree for JSON. And I had to wrap this into my own types, and they are still there, but now I'm not using the boost stuff, but I'm using 30, and we don't need this property tree stuff anymore. We could just directly use 30 JSON here. So I think we can. This is the first good cleanup. So that the message has a direct reference on the 30 JSON value. Yeah, let's start there. And then let's see where we end up. Yeah, it's not rigged. The wheel isn't rigged. Let's wait and see. The evening isn't over yet. So yeah, these are the messages we can send. They always have a topic, and then they have just some JSON attached to it. And yeah, you have to subscribe to the topic if you want to receive the messages from the stream. And let's maybe just have a quick look at the unit tests so that you can see it in action. So that is WebSocket CPP in core test. Let's just pick a smaller one. They are all way too big. It doesn't matter really. So what we have to do is we connect to the port, and then we send a subscribe, a JSON payload that says subscribe and the topic we want to subscribe to. And once we've done that, we receive, in this example, we receive election stopped messages from then on, from the time where we send the subscribe command. And we can also unsubscribe, and we can change the subscription options. Like you can see here, we have some additional options. I don't know what they do. I just ported the code, and I did not really try to understand it deeper. But maybe we will gain a deeper understanding today. So let's get back to here. Yeah, so we have the listener. It listens. It launches all of those WebSocket sessions, and then you can send and receive messages. So it has, the listener has, let's maybe add a couple of functions. It has a broadcast function, and that we can call to broadcast a message to all open sessions. Broadcast, here it is. As you can see, it just goes through. Ooh, what was that? Broadcast. Yeah, so it just goes through all the running sessions, and then it just clones the message and puts that into the write queue of all of those sessions. So there is broadcast confirmation, which I find odd because it is so specific, and maybe we can move this out of here. I'm not sure. Let's postpone this. So we have broadcast, we have broadcast confirmation. And of course we have run and stop. You know what? These are better names. Start and stop. So let's rename run sync into start. So this is actually start, because now we have a start and stop pair. That's much better. And run makes sense because I'm expecting run to only return once it's done. And I think it does that. So already a better cleanup. So let's add that. So we have start and stop. Broadcast and broadcast confirmation. And then we have all of those helper functions, and I'm not going to add them. Stop. What is stop 2? I really don't like those names. Let's also rename that. So this is the sync stop, and this is the async stop. What does this do? It drains the sessions. Okay, chat, now you could help me. We need better names. So we have the synchronous stop down there. Where is it? Here it is. We have the synchronous stop, and what it does, it switches here to the Tokyo runtime, and then it calls the stop, the async stop. I'm just calling this stop async for now. So these small changes, I think they really add up. And I read a book from Kent Beck recently, and it's called Tidy First. And he talks a lot about those small improvements and how they add up. And I think he is spot on. So it really is worth making those small improvements. LF says, but won't you also remove the sync stop method? Yes, I will. So maybe just keep the ugly name for now. You know what? I could also... Yeah, I could also... You know, I could also rename it again when I remove the method. I just want to keep this in line. I could call this stop sync, but then we would have a start and a stop sync, and I would ask myself, like, why are the names so different? Let's just keep it like that. And let's rename it once we remove it. And I also wanted to split this file up because this file is huge. It has 800 lines and it contains a lot of different things. So let's split this up. It contains options, confirmation options. I want to create a file for every struct, really. Are you with me, chat? What's your opinion about files? Do you like large files? Do you split them up? I like to split them up. And I don't mind if a file just has a couple of lines of code. But that's a taste thing, really. What's your preference, Nano fan? I want to add a mod here called options. LFLF says small files are better in my opinion. Okay, so LFLF is on my side here. Options. So let's move the options code to the out of listener. So that is, should we move all options there? Yeah. Oh, now I heard it. Now I heard the Bitcoin block music. Where is it? Here it is. Wanderson, Nano is the light. One Nano for you. Oh, you didn't hear it again? Oh, maybe it's not captured. Maybe my audio output isn't captured correctly. Sorry guys, it will work in the next stream. LFLF says, but at the scale of RsNano, it might even make sense to refactor some parts as own libraries. Oh, I fully agree. For example, the web service implementation or WebSocket implementation could maybe be generalized and detached, right? Yeah, I like that idea. I like that idea a lot. That's also my goal, to make the code base, to split the code base up into smaller self-contained modules. And I already did it a little bit. So as you can see here in this tree, we have core with the core types like block hash, account, public key, private key, and all of those basic types that we need. And we have the ledger, which contains the database, the ledger implementation. And then this crate here is messages, which only contains the messages that nodes used for communication. So whenever you want to connect to a nano node, you could use this crate here, and you could use the messages structs. Yeah. And of course, we should split the code base up into more reusable modules. So let's... Yeah, so... Yeah. I had a pause there. Okay, yeah, I want to do that. And I also want to make the WebSocket code a bit more generic. I'm not sure. Let's see where we end up. So the options. I wanted to move the options to their own file. So let's move all of them. It's a lot of code already. Vote options. Oh, it's so much code that maybe I want to split them each into their own file, maybe. Because then I can also add tests for each of them at the bottom of the file. Yeah, I'm gonna do that. So let's pick options enum and move them to options. And now let's create a file for the confirmation options. Oh. And let's move the confirmation options into that file. Confirmation options. So we have to import a couple of things. Wallets. Why do they need the wallets? Strange. So serialize. Okay, we have more errors here. Warn. Count. So I just have to import the missing structs and functions. Property tree. Yeah, so I want to get rid of the property tree completely. Okay. And now let's do the same thing for the vote options. The vote options. Both options. And let's import all of the missing things. Import warn. Import trace. I also added a bit of more tracing to the WebSocket code because I had some bugs in there after I ported it, and so I added more tracing. And the tracing crate from Rust is really nice. So I import message. Okay, that was it. No more errors. Fortune1 says, do you use any large language models looking for structural improvement simplifications of the code? No, I haven't yet. Do you think models like Cloud, how do you pronounce that, are of any use for that? I think so, because AI is really progressing well, and I could imagine that AI would be really good for code reviews or suggestions of how to improve the code base. Claude, the French guy. Claude. Okay, let's call it Claude. Or Claude. Let's pronounce it German. Claude. Options. So we still have some missing imports. Let's use the confirmation options and the vote options. Let's fix all of that. All right, vote options. Okay, that was it. So what else do we have here? We have incoming message. WebSocket session entry. WebSocket session entry. Yeah, so I want to move the WebSocket session into its own file. Let's do that. WebSocket session. And where does it end? Here. WebSocket session. So now we have to import arc and who. Let's first import the other ones. Wallet. What about the WebSocket session entry? Oh, maybe I should copy that too. Yeah, let's also bring that one over to the new file. Okay. And WebSocket session, let's use all of that. Let's make all of that public. So, where was I? Session here. So still, oh, giveaway time. Time flies so quickly. RsNano goes to Cropter again. I think you rigged the wheel this time. There you go. Okay. So we need to import hash map. And we need to import topic. And options. And message. And we need one shot from Tokyo. And MPSC from Tokyo. Crafter says, feels good to be a winner. I have away 4 nano today. Got back half now. You gave away 4 nanos today. Like, what's the story? Who do you give it to? Remove the await. Oh, I think I imported the wrong... Yeah, I imported the wrong MPSC. I have to use the one from Tokyo. Yeah. So... Atomic use size. Socket address. What else? Trace. So this is tracing. Great. What are all these warnings here? Crafter says people at work trying to get them to try it. Oh, that's good. From my experience, once you can tell them all about Nano, but once they try it for themselves, then they are impressed. Copter says, what is hard is convincing them to download a wallet and giving away crypto for free without sounding like a scammer. Yeah. And our whole crypto industry, it's just known for scams. And when people ask me, what do you do all day? And I say, I work in crypto. Like, it's... I always have to say, but it's not a scam, and but it's not energy wasting, and we are actually working on a currency and not trying to get rich quickly. Yeah, it's a shame that our whole crypto space has such a bad reputation now. Incoming message, could not find type. Okay, so we have to move them. Oh, it's not pub. So let's make all of them pub. Traced. We don't need to trace anymore. WebSocket session entry. Ah. Generate, no. Is the WebSocket session entry also not public? No, it's not public. So let's make it public. They are, Crypto says they are not really that impressed since they have not tried any other crypto. Yeah. Oh yeah. So also, yeah, I agree. Like when people have just ideas about, let's say, Bitcoin, and then you show them how to use it, and they are just like baffled how hard it is with the fees and the time it takes, the confirmations. LFLF says, I try to describe Nano as a digital currency, not a crypto one. It doesn't sound as bad. Yeah, but if you look at it, it is the heart of cryptocurrency. Like it is the very idea of cryptocurrency. Yeah, it's just bad that the term cryptocurrency got polluted. Crypto says, so they got nothing to compare it to, but I guess they will be unimpressed by other cryptos if they try them. Yeah. Well, no, I had friends and I sent them nanos back and forth, and they had never used crypto before, and they were really surprised how easy it is and how fast. So stream.next. So we have to import futures util. contents is 30 property tree. Yeah, we have to import that property tree, and I hope that we can remove that in the stream. What's missing here? Futures util. Coming message. Oh. So many errors still. We need 30 JSON value. We need 30 property tree. Milliseconds since epoch. To topic. Confirmation options. And confirmation JSON options. Or maybe we can come up with better structure or better names. Because that is also confusing that we have vote options and we have vote JSON options. So what's the difference here really? Ordering and info. Okay. So that was that was it with the imports. WebSocket session entry. Import that. Even more import errors. Session.close. Oh, we don't have access to the close field because it is private. Okay. So what this is here is, I think the anti-pattern is called feature envy, is when we grab into other objects' state instead of letting the other object do the work. And this is I think a typical case of feature envy, because what these three lines do is they want to send the close signal to the session, and it is done in the listener struct, and the listener struct is not the right place for that. So I want to copy these lines and I want to put them into our WebSocket session entry, and I want to have a function called, well, let's put it here, close. So pub fn, is it async? No. Pub fn close. And does it have to be mute? I don't know. Let's see what the compiler says. So no, it doesn't have to be mute. Okay. Oh, we have a okay. We have a field called close. It's a one-shot channel, and we are transmitting the close. Let's rename this to tx close, because this is the transmitting channel. tx close. No more arrows in here. Okay. So let's go back to listener. Yeah, and now we can call our new function. We just say session.close Bitcoin block. Yeah. See? A small change, but it makes the code just a little bit better. Cropter says, when you are finished porting the node to Rust, will you make improvements to the node that will need to be ported over to C++? So that's not my decision. The changes I want to make are structural in nature first. So I don't want to change the algorithms or the features. I want to change the structure of the code, and I want to improve the test suite. Let's run the spinner wheel. Oh, sorry. Let's run the spinner. Mark Sarno, you won a nano. Congratulations, Mark. Yeah, so I want to split up all of the big classes. I want to split up all of the big functions. I want to, just generally improve readability, and I want to make the tests really, really fast and focused. So that we can just easier work with the code. And I also think that the core team is currently doing a really good job at improving the code base. So I think V27, that will be like a huge release with a lot of changes in them. Okay, so blocking right is private. Okay, so we have to make that one pop and that one pop. And filter should be pop. No, this is a helper function. We don't have this. Is okay. Okay. So the next problem we have is down here. Subs. So what does broadcast confirmation. So this is something that I would change here. It is, first of all, it takes a lot of arguments. So I don't like, I'm on Robert Martin's side here. I like functions to be small. I like them to take as few arguments as possible. So that is way too much for my taste. And the function length here is also way too much. And I would like to refactor it to use the nullability patterns from James Shore. And that also means that I should separate the code into infrastructure, logic, and application. The 3 layers. A very simple pattern. I've shown it a lot of times in these streams, and I'm a huge fan of it. Okay. So what's wrong here? Session.subscriptions.log field. So this is again private. And maybe we should also move this out. But I don't feel comfortable making these changes while we are still in a broken state here. So I want to make it pub for now, and I want to remove this pub as soon as we can compile. And yeah, so one improvement after the other. I don't want to overdo it here. So let's first remove fix all of the errors here, and then let's improve it further. So okay. You know, I just said I don't want to improve it. I just want to fix the errors and then improve it, but this is just a small thing. I just want to add a new function here. And this new function would take just this here, the tx send. And the close tx. Those two. So it would take this. And it would take this. The one-shot sender. So send tx close, and the subscriptions are mutex hash map new. So it's empty when we create it. And now we can use this new function here. New with tx send and close. And I find it weird that one is called tx send and the other is called close tx. I want to have them the same style. So let's rename close tx to tx close. Antefnal says that's how it starts. Oh, I think I missed that comment. I don't remember. Oh, just this small. Oh, yeah, you're right. You're right. You know, like just last evening, the WebSockets didn't work. The rewrite, there were some bugs in it. And I said, last evening, I said to my girlfriend, oh, I think I just need 15 more minutes to fix it. And then I'm shutting down the PC. So I sat down. And I really thought it would take me 15 minutes. And 2 hours later, I gave up in frustration and I shut down the PC and it didn't work. It still didn't work. And today I spent another 5 hours fixing the issue. So the 50 minutes was like 7 hours of work, actually. TX Texas. Yeah, and, this is from the channel stuff of Rust, where when we create a channel, we always get a sender and a receiver. So I think I just copied the naming from the tutorials. So we have a TX which does the sending, and we have a RX for receiving. Or maybe it's better to call it close. TX close RX close. So this part of the channel we can use to send a message, and this part of the channel we can use to receive the message. So WebSocket session. What's wrong? What's wrong? The new function is private. Okay. Let's make that public. Johnny Alstrom, sorry I'm late. No problem. Adding you to. Oh, did that add you? Yeah. Okay. So we are just currently cleaning up the code a little bit. So this is just a very slow-paced cleanup stream. And I just wanted to try out if this is suitable material for streaming. Please let me know, like, is this boring if we clean up the code, and is the slower pace? What do you prefer? The faster pace stuff where I work on stuff where I really know what I want to do, or the slower pace stuff where I'm just like trying to figure out where I want to go? Okay, we have a lot of unused imports now. Hey, no more warnings, no more errors. Okay, so we have, let's check this file. So we have, Andefna says, I like it like this, small refactors where I'm not completely lost. Okay, yeah. Yeah, I also like, so not that you guys have the wrong impression. I'm not like spending the whole day like, oh, hammering the keyboard and yeah, spitting out code. So there's a lot of time where I just slowly try to find my way. Incoming message. So what is that? Incoming message. So this is the JSON data that we receive, and let's move it out of this file and maybe into mod, because it's just a very... is this a good place for it? I'm not sure. 30... Oh, give away time. Value. Johnny says slow is smooth, smooth is fast. Okay, let's go. Craptor again. This wheel is rigged, guys. It is rigged. 1 nano for your Craptor. And the time is running, okay. So now the listener file contains the WebSocket listener struct and all of that. And yeah, I had to even like add this extension trait so that we can use it in the sync code. Accept connection. Does this belong to the listener? It does. Yeah, of course it does. Okay, now we're down to 263 lines. That's better. Let's have a look at the diagram again. So now the WebSocket listener is in its own file. The session and the entry are in one file. Where is topic? Oh, I think the topic is in the message file. And I think that's okay. So here, these are all the topics that you can subscribe to. Message. So I want to commit this first. So let's do a quick check. Cargo check. Oh. Options RS. Vote options missing. And message is missing. And property tree is missing. Another check. WebSocket session RS. Mismatch types. One shot. Oh, okay, it is, yeah. I have to pack it into a mutex option here. So mutex new. Sum. X close. Crafter says, now I just need one more and I break even for today. Yeah, I do my best, Crafter. And since you're giving them away too, that's actually really good. So let's create a commit here. Let's reformat the code first. So cargo format do, and let's check what all of our changes. Yeah. We moved all of that into their own files. And let's write a commit message that says split or move WebSocket code to separate files. Let's push that. Okay. So we pushed that. So I think we could now move on and change our message so that it doesn't use this property tree code anymore. So I want the message to contain the JSON, the 30 JSON struct directly. So how many references do we have to the contents field? Quite a lot. Okay, so... one... Yeah, let's do it in one go. What do you mean, Jet? Small steps, one go. I want to do it in one go here. I don't expect this to go wrong. Famous last words from developers. So I want contents to be of types value, 30 JSON value. And now we will get a lot of errors here. So new is value null. LF says one go always goes well. Yeah, of course. Like it never failed for me. It always went well. Null. Who calls this constructor with topic and no content? I don't think we need this anyways. Yeah. Here. Okay, so they are setting fields here, so we can't use null. Let's just say object, an empty object. Object takes a map. Okay. So next error is here. So message.contents. So Bootstrap. Okay, so this is the message builder. And this creates our messages. What does new message do? Bootstrap. Topic is the... Okay. Okay, NanoFam. How can we improve that? I don't want to create the message here because I don't want to make it mutable. I think we can just create the message in one go and return it. So I think we can just say contents add child. There's also a lot of repeating code here. So we always add the message with the actual data. And we always call this new message here. And we always set the common fields, right? No? Bootstrap started, Bootstrap exited. What are the common fields? Common fields are the topic and the time. And why are there no common fields in these two? No, there's here. It's here. But there's no common fields in here. No, there's here. It is here. But here the bootstrap started, bootstrap exited is missing the common fields. So I hope it wasn't my mistake here. Maybe I forgot that. So let's just, I just want to make sure on GitHub, just quickly. WebSocket CPP. And what was the name? Bootstrap started. Oh, yeah. Oh, bad. And it's also bad that the tests don't test this, but I forgot to set the comment fields here. Ooh. NanoFam, you got me. I made a mistake here. So let's call self, set comment fields. Message. Getting a result. So we have to do that here and here. And that's the problem with all of that repeating code. Because you can forget it. Like, so you remember to set the comment fields 10 times, and the 11th time you don't remember it. And that's the problem with this repeating code. So I want one function that does it, and then I can never forget it. So 1 nano 4. Wenderson! Nano is the light. Wenderson. Okay. Timer running. Okay, so they all have that same logic. So they create the message, they set the comment fields. So what I want to do here is, instead of doing it like that, I want to refactor out the commonalities. And I just want to create the bootstrap content as a value. No, as a map. And then I want to say insert started is value string. And this cannot fail. A lot of typing, so I'm not happy with that really. Insert, so a lot of unnecessary code here. To string, so that to string I find unnecessary. And the value string, yeah, don't like that. And mode. You know what I would prefer? I would prefer to use a struct and then to serialize the struct. But let's do it in small steps. I think we can move to the struct soon. So what is mode is also a str. And it must be a value string. Yeah, I think I want to move to real structs here and then just serialize them. So contents is a value, so we... Okay. A value. How can I add a child here? Should we move to a struct directly? Because I feel like we would spend a lot of work here just converting all of that to the values, And then later we would rewrite it a second time with the structs. Reason ID mode. With the struct, let's try it out. Let's sketch it. So with the structs, let's add a struct here. So struct bootstrap started, and it would have be serializable, and it would have reason, and that would be a string. No, or could even be a ref. Yeah. Let's keep it simple. Let's keep it simple. We can always make it better once it works. So let's just make reason a string and ID a string and mode string. And down here, we would say bootstrap is bootstrap started. And then we would say reason is started. And ID would be... What is ID? Like that. And mode would be... The code will reveal what it wants to be, says Anfmal. You are right. Yeah, the code talks to us. If you move slowly. We just have to learn to listen to the code. What the code wants from us. So mode is... What is mode? It's also a str. So these are all just strurs. So I think we can just say... Yeah. Let's just make them... Let's just make them strurs. Because it's just so simple. Like, these are just so small function. And it's only used here, so why not like that? So we can just delete all of these two strings. And mode is also here. Mode, okay. Bootstrap. So we have the bootstrap message now. And we can delete that. And now let's refactor these lines that create the full message. It has a topic. Yeah, maybe. What are the common fields again? Topic, time. Topic and time. And message. I think we can also create a struct for that. But we can't call it message. We have message already. So what is this? I'm calling it JSON message now, and this is a bad name. But I just want to get started. And we are going to improve the naming soon. Why is that so high? So the JSON message is it has the message field here, so that would be message of would be a value, a JSON value, and of course it can be serialized. Oh, this is an outgoing message. outbound message. Because we have incoming messages and outgoing messages, and they are different. So maybe we could just call this outgoing message. And the common fields are topic as a string and topic as a string and time as an int. Ooh. Here, so topic as a str. Time as u64. Oh wait, is it? Is it a u64? Because the C++ JSON stuff is really bad because the boost property tree treats everything as a string, as far as I know. Yeah, no, time. A string, yeah. So this adds the time as a string. And I want to keep it like that just to stay compatible. Giveaway time. Let me just quickly finish this. Is the time a string or a u64? Or are we going to break compatibility? I don't want to break compatibility, so let's make it a string. So outgoing message has topic, time, and message. But let's first spin the spinner. The lucky winner is Heis. There you go. LFLF, where is this message sent to? This message goes to the client that connected to our WebSocket. So the client connects to our WebSocket, then it subscribes to the topic bootstrap, and then it will receive whenever a bootstrap is started. So yeah, so here I want to create the message as an outgoing message, and the fields. So let's just copy that from the set common fields, and then we can refactor that. So the topic is from message topic. Message.topic. What? What's the message? What's the topic? Oh, the topic is here. No self message. The topic, we gave the topic in the self new message. So the topic is topic.bootstrap. That's so confusing. Okay, so the topic is topic bootstrap Esther. Then we need time. So let's just copy the time from down there. the message will be bootstrap. Ah, yeah, we have to create a JSON value out of it. So how do we do that? 30 JSON to value. Convert a T into a value, which is an enum that can represent any valid JSON state. Let's try that. And T is bootstrap. Oh, this can fail. Okay. But it shouldn't really. It shouldn't fail. Okay, message is that. And now we have the message and we want to return it as... What does this... Oh, this returns message, topic, and contents. So this will be ugly for a bit, but I think we can make this really nice and clean. Now we have to convert this outgoing message into this other message struct, which I find very odd. But I think we can unify them. Message new with the contents is there. Let's move that up. Okay, these are pop, these fields, so we can just set them. So let's set them. So topic is, again, topic bootstrap, and contents is, now we can serialize the message. Into what? Into a value. So again, 30 JSON to value. Message. Oh. JSON. LFLF says, then breaking compatibility isn't really an option anyway, right? Yeah, I want people who wrote code against the nano node to be able to use their code without changes when they want to switch to RsNano. So yeah, that's why I want to keep it the same. Okay, so now this part here, we will use this in all of the other message functions too. So now we can extract this into a helper function, and then we can just rewrite all of the other functions here in the same style. And that will clean it up a lot. So let's move that. I wished I had done it in smaller steps, because now I have to make all of those changes in one go, and I cannot run the tests in between. If I had made smaller steps. Yeah, but now I'm in the mess already, so let's pull it through. So this should be a helper function. And that function, let's name it, how should we name it? Create message. And what are the arguments are... so it has to take the topic. And it has to take the message value, and that has to implement serialize. So we can just say message impl serialize. And it returns a result message. So let's move that code here. And let's call it down there. So here we say create message, topic, bootstrap, bootstrap. And here we have to say topic as string and to value message. And again, we have to say topic. It's topic. Does it look better when we inline it? Yeah. See you, NanoFam. This is now just a lot smaller and easier to read. I like it. And because this is a helper function and I don't need to know what it does, I want to move it right to the bottom. So let's now use the same pattern for the other functions. Bootstrap exited. So that also needs reason, ID mode, total blocks, duration. Okay, let's add that. So we add a struct called bootstrap exited, reason, ID mode, and then what were the other ones? Total blocks U64. Duration U64. Are they really put as a U64 or as a string? They are put as a number. Okay. So total blocks and duration. Okay, so let's do the giveaway. LF, I wished I had done it in smaller steps. I think you ran into the same situation already multiple times, but still try to do everything in one go. Yeah, I'm uncurable. I'm uncurable. What? Oh, Jubu, congratulations. Okay, so now let's do the same pattern down here in Bootstrap exited. So we just say topic is Bootstrap, yeah. And then we say the reason is exited. The ID is ID, the mode is mode. And then total blocks is, oh, let's start it, exited. And total blocks is total blocks. And duration is duration as seconds. Yeah. Yeah. And we can remove all of that. That's just, yeah, I like it. It's just cleaner. See, these functions, they are just a lot smaller now. Nicer to read. So let's do the same for telemetry received. Just copying that. So what is going on for telemetry received? The topic is telemetry. And is the timer running? It is, yeah. And the message is telemetry received, and it has address, port, and what is that? Serialized JSON. Oh. Do other people use this now? Ah, we are lucky, chat. We are lucky because this is the only usage of the function. So we can change it in whatever way we like. So let's create a struct first. And the struct is telemetry received. And we have to add address, port, port, and we have to make it serializable. And how to handle the rest of the telemetry information. This just calls serialized JSON. Address, port. And this is the only usage, so we can't change it. We can change this. Maybe let's just inline that. Because no one else is using it. And those fields are those fields public? I think so. Pub. All of those fields are public. I want to inline that. So maybe let's go back and let's add them all here. So that means we have block count, and that is U64. Segmented count, U64. Check count. Count. Is there a faster way? Yeah, let's just do it by hand. Count. What was that? And check count. Count. And with cap. Also U64. Here count. What is peer count? That's not a U64, that's a U32. Protocol version. Hey Bob, how are you? I think those conversations and struct creations would be ideal task for GPT-4. Yeah, probably. I really should use that more often, because I'm not using that right now. Uptime. The Genesis block is a string. It's a major version, minor version, patch version, pre-release, and maker. So now we have timestamp left, timestamp, and active difficulty. What about those fields? Ignore identification metrics. Do we use them? We don't. We don't use them, so no need to add them. I think that's it. This is the telemetry received message here. And now let's just create it. Create that here. So we say telemetry received. And Let's fill the fields. And what is the telemetry data? It's up here. So we say, maybe I don't want to type so much, so let's just rename it to data. So that is data.block count. Oh, that's a boring task. Oh, I mistyped. Data cemented. Data unchecked. Data account count. Bandwidth cap. Protocol version. So the Genesis block, we have to say, we have to take the hash. What? Oh, it is a hash already. We have to convert it to string. Major version is major version. Minor version. Batch version. The maker. And if you remember from last stream, we have our own maker number, which is the number 3. Timestamp is data timestamp duration since Unix epoch as millis. SU64. Active difficulty. Oh, we have to format that active difficulty in hexadecimal, so let's maybe change that into a string. So that we can do that here. So format. What's the format? Hexadecimal. Okay. Okay. Address and port. So that is address is endpoint IP, the string, and port is endpoint port. So yeah, give away time, but I just want to finish this. Yeah. We did it, chat, we did it. So this is the new telemetry received. And now we can remove this one from the serialized JSON function in the telemetry data because no one uses it anymore. Yeah. So let's delete that code. And we simplified it again. Let's delete all the things. Yeah, and if not, I love deleting code. Oh, time is running out. Just 10 minutes left. Jubu again. Congratulations. So the last 10 minutes of the stream, guys. The last 10 minutes. Okay, so we have the telemetry received. We have all of them. So let's now go to the new block arrived. And what does that contain? The block. It serializes the block into JSON. And then, oh, something open here. And Efnal says, this wheel is rigged. What do you think, LFLF? I told you it is rigged. I told you. I don't know why the other wheel didn't load. Maybe it was a spam attack by one of you guys so that I would use the old rigged wheel again. It's unacceptable that you didn't get a single nano, Andef. Oh, you didn't. Andef, no, didn't you get any? Not a single one. There's one nano left, right? No? What? Guys, there are no nanos left. I gave away 10 nanos already. Oh, I'm sorry, Andefnall. We don't have any nanos left. Corruptor says, I think the spinning wheel is working really good. Yeah, for you. Okay. So block. Block L, serialization. So this serializes the block. Yeah. Okay, this serialized JSON function is being used a lot. And then what does it do? It adds a subtype and then it adds it here. I think we have to cheat a bit here. So I think we can't remove the property tree here yet, but that's not a problem. We just keep that code as it is. I don't like block L as a name. I want to call it block JSON block. Subtype. Okay, and then down here I want to call our function. What was the name of our function? Self-create message. Create message, and the topic is... What's the topic? New unconfirmed block. And the message would be JSON block. And this is okay because no, JSON block dot value, because the value, the 30 JSON value, is serializable. So this here, it is not as nice as the other functions, but I have to revisit it once I have refactored the other places that use the JSON block serialization. Andefla says, by the way, I won 32 nano so far. 32, wow. LFLF says, does it make sense to rename message L to JSON message 2? Yeah, where did you see message L? So this is the old naming style from the C++ code base. And I just, when I ported it, I just copy-pasted it and I never changed it. But I wanna change names, yeah. Message L. Alright, yeah, we will find it. So the new block arrived. The next one is started election. So started election just has hash. So this, let's just port these two functions and then we end the stream. So struct election. Started and stopped election is the same. Started election as a hash. Serialize. So let's say self create message. Topic is started election, and the message is started election, and the hash is hash to string. Then we can remove that code. Oh, this looks so much better, chat. See? I like that. I really like cleaning up the code, making it smaller, more readable. This is just so much better than the old version. But I want to stop here, really. So I'm going to finish this tomorrow, cleaning up these remaining functions, and let's create a new branch here, so that I don't want to commit unfinished stuff to develop. So let's create a new one. Zip refactor message builder, and let's add everything there. Refactor message builder. Okay, what have I missed in the chat? Crafter says that is $32,000 when Nano got Bitcoin's market cap. Yeah, let's hope that we reach that one day. All for watching some streams. I think these streams could become popular then. Let's when Nano ever reaches those prices. Yeah. You removed message L after I wrote my message. Okay, but there was message block L. Okay. Okay, chat. So that's it for today. Let me know how did you like the smaller, the slower stuff? Was it okay? Is this type of refactoring work interesting to watch, or would you rather see something else like porting code or I don't know what, unit tests maybe? Was fun as always, LFLF. Thank you. Yeah, same for me. Fun as always. So the next stream will be next Tuesday. Same time, same place. Yeah, have a good night. And I'm also going to sleep now. So, Wenderson, thank you for your time. You know, thanks for watching, guys. And yeah, cheers to everyone. Have a good one. Bye-bye.